Students, this is the solution video for the MJ 2019 paper 2-1. I'll be showing the working for each question. So if there's a specific question you would like to jump to, please use the timestamps available in the description below. Also, if you need to copy down any working, please pause the video as I'll be tackling the questions one after the other. Without further ado, let's begin. So for our first question, we have 1.20 as a percentage of 16. So all we need to do from here is just take a division. We take 1.20 divided by 16 and we just immediately multiply by 100. So this one is calculator work. So from our calculator, we will have 1.20 divided by 16 times 100. That would be 7.5%. Right. So for question number 2, factorize 5y minus 6py. So we are factorizing out the common terms. We check the number first. 5 and 6, they cannot be divided any further, but both terms have y in common. So we will take out the y. So we are left with y bracket 5 minus 6p. That's done for number 2. For number 3, it is just calculator work. So we can just input the cube root of 8.1 square minus 1.3 to the power of 0.8. So we take our answer to 3 significant figures, which is 4.01. Which is in 3 significant figures. Now in question 4, equilateral triangle has sides of length 15 cm, correct to the nearest centimeter. Calculate the upper bound of the perimeter of this triangle. So take note, this is the perimeter of the triangle and the upper bound. So let's take up the upper bound for the length. So let's call this LU or L upper, right? So the L upper would be 15.5, whereas the L lower will be 14.5. So if you are given a specific type of bound, because this is correct to the nearest centimeter, or in other words, it's the nearest 1 cm. So if you take 1 cm and you divide it by 2, we get 0.5. So this is how our bound is going to split. So that means if we have 15 cm, we're going to add 0.5 for the upper bound, and we're going to subtract 0.5 for the lower bound. So this is 14.5 and 15.5 respectively for the upper and lower bound in that sense. So from here, since we know L upper is 15.5, so this is an equilateral triangle. So therefore, the perimeter for the upper bound of the perimeter, I should say. So we can just say P upper would be 15.5 multiplied by 3, or 15.5 plus 15.5 plus 15.5. So that will give us 46.5 cm. Right. So that is for the first 4 questions. So moving on to question number 5. So in question number 5, we have the volume of a cuboid. So just place it up here first. So the volume of a cuboid is volume of a cuboid is 180 cm cube. The base is a square of side length 6 cm. Calculate the height of this cuboid. So the base is a square. So since the base is a square, we have 180. Or we can just say length times width times by height is 180 cm cube. So in other words, this is 6 multiplied by 6 multiplied by height, 180 cm cube. So that's 36. H equals to 180 cm. So H equals to 180 divided by 36 on both sides. So that is H equals to 5. So we divide 36 here, divide 36 here for the calculation. Right, so we have H equals to 5 cm. So moving on to our question number 6 and 7. So putting it out here. So for question number 6, we have simplify t power 21 divide t power 7. So they have the same base. So if we are dividing and they have the same base, we will just work with the indices. So it would just be t21 minus 7. So immediately we'll have t power 14 to solve. Whereas for this one, for B, we have u power 5 to the power of 5. So if you have power on power, we multiply the powers together. So it will be u to the power of 25 immediately. And that's done. So for the next question, diagram shows a right angle triangle. Calculate the value of x. So we are given an angle and a length. So we know that based on the angle, this is the opposite, adjacent, and the hypotenuse. So based on what we have the opposite, or we're looking for the opposite to be precise, and we have given the hypotenuse. So in other words, we'll be using SOH. So that means if we sine 35 equals to opposite over hypotenuse, which means sine 35 equals to x over 12. So x equals to 12 sine 35. So that can be done on a calculator to three significant figures. So that would be 6.88 cm. These are three significant figures. So that is for question number 6 and 7. So moving on to question number 8 and 9. So we have number 8 as a circle and number 9 for recurring decimal question. So for number 8, we are starting off with A, B, and C are points on the circle center O. Find the obtuse angle AOC. So obtuse angle in this case is an angle that is between 180 and 90 degrees. Not inclusive, so I wrote the symbol wrong there. So that's not inclusive. Now, basically, we are looking for this. We can't look for the other direction because the other direction is more than 180 degrees. It's the reflex angle instead. So we are not interested in this. However, this is the angle at the circumference and this is the angle at the center. So basically, one of our circle concepts is that the angle at the circumference is we should say, I usually say the other way around actually. So the angle at the center is 2 times the angle of circumference. So in other words, we have the reflex angle AOC. So AOC reflex will be 130 multiplied by 2. So that would be 260 degrees. So in other words, obtuse AOC would be 360 minus 260. So that is 100 degrees. So that's done. So in question number 9, we have write the recurring decimal 0.47 recurring as a fraction. So when we want to write recurring decimals as a fraction, we have 0.477. We can just like write it like this. We can let x equals to 0.4777. Now, from here, we are going to try to move the terms. So we're going to multiply both sides by 10. So we have 10x equals to 4.777. Right. Now, from here, you can actually subtract already, but if you want the number to look a bit nicer, you can multiply 10 one more time. So we get 100x equals to 47.777. Right. So in other words, I can call this equation 1, equation 2. So I can say equation 2 minus equation 1. So it'll be 90x equals to 40. So from here, we will have equals to 43. So x equals to 43 over 90, which can't be simplified further. So that is our answer in fractions. 43 over 90. Right, so if you were to do it here previously, that means if you took this as equation 1 instead and this as equation 2 also can be done. However, the number won't end up very nice. So it'll be 9x equals to 4.3. So x equals to 4.3 over 9. But you multiply 10 on top and bottom, you get 43 over 90. The same answer will still be obtained. But you cannot write your answer like this because you can't combine the decimal and the fraction together in this way. Right, it's either you write everything in fractions or you write everything in decimals. You can't go in between, yeah? So that is for question number. So moving on to number 10. So number 10 is functions question. So we have this here. So for our functions question, we have fx equals to 2x plus 3. Find f1 minus x in its simplest form. So whatever happens in the x in the function here applies to the x on the equation on the right side. So in other words, it will be f1 minus x. We are simply replacing the x with 1 minus x plus 3. So we're going to simplify. This will be 2 minus 2x plus 3. So 2 plus 3 will be 5 minus 2x. Start. Yeah. So moving on to our next few questions. So we have question number 11, 12. Yeah. So we are doing first. So from here, the diagram shows 5 cards. 2 of the cards are taken random without replacement. So without replacement, take note that you do not put it back into the container. So we're just taking it out. It's no longer in the pool. So from here, find the probability that both cards show an even number. So probability of even, right? So we want even and even. So what's the probability of an even number first to start? So probability even is just there are 2 even numbers here. So it's 2 over 5. So therefore, the probability of even and even would be over 5 times 1 over 4. So 1 over 4 because this is done without replacement. Yeah. So you remove one card from the pool, you remove an even card from the entire pool as well. So From here, you get 2 over 20, which simplifies to 1 over 10. And that is your answer. So for number 12, so from the list of numbers below, write down a multiple of 7, a cube number and a prime number. So multiple of 7, you can just choose literally anything. So there's only one actually, so it's just 28 here. So 4 times 7 is 28. Therefore, it is a multiple of 7. Cube number is basically a number that has been cubed. So from here, 27 is basically 3 cubed. So our answer will be 27 here. And lastly, a prime number. Prime number is a number that can't be divided by any other number aside from 1 in itself. So that will be 29, right? You can also select 30 if you want to, right? So either or is okay, but you can just base it a prime number. So you write 29 or 31 is acceptable, right? In this case, do not write both. If you write both, you will be considered incorrect because they ask for one prime number, a prime number. So it's for number 13. So question number 13, it is completing the square question. So for our completing the square question, we will have find the value of a and b from x squared plus 4x minus 9 to this form. So from here, this has already been simplified, x squared plus 4x minus 9. First thing we check is that this term here the coefficient has to be 1. So since the coefficient has to be 1, in this case, we are going to continue with our method. So x squared plus 4x minus 9. So first of all, we copy down the first two terms, so x squared plus 4x, and then we add the b term over 2 squared, subtract the b term over 2 squared, and minus 9. So the b term in this case is in the general form of the quadratic. It is ax squared plus x plus c. So we are in the completing the square method, we take the b over 2. So the formula looks like this. So it's kind of like a, or in this case, x squared plus bx plus c. So it will be x squared plus bx plus b over 2 squared minus b over 2 squared plus c. Right? And after that, we will condense this part here to become x plus 4 divided by 2 is 2. So it will be x plus 2 squared. This term disappears. So minus 2 squared minus 9. And then finally, we end up with x plus 2 squared minus 4 minus 9, x plus 2 squared minus 13. Therefore, a is 2. B is negative 30. Right. So this is question number 30. Right. So for our next 3 questions, we have 14, 15, and 16. I believe most of you should not have a problem with 14, but I'm just showing the working here just in case you guys want to see clear working, because the 3 marks means they literally want everything short. So you can't miss a beat. So from here, it'll be 5 to 6 plus 2 over 3. First things first is to make the denominators the same. So we multiply 2 on the top and bottom for the right fraction. So it'll be 5 over 6 plus 4 over 6. That will become 5 plus 4 over 6. And it will just become 9 over 6. So they want the answer in a mixed. So from here, we simplify the fraction first, divide 3 on the top and bottom. So that will be 3 over 2. And finally, convert it to mixed number, this will be 1 over 2. Right. So that is your working on question number 14. So for number 15, it is an expand and simplify question. So we are just going to expand the first 2 brackets first really quick. So x squared plus 2x plus x plus 2. We take x times x times 2, 1 times x, and 1 times 2. We end up like this. So from here, 2x times x and 2x times negative 3 is 2x squared minus 6x. So we will work with the x squared term. So x squared plus 2x squared will give us 3x squared. 2x plus x minus 6x will give us minus 3x. And finally, we have plus 2 as the constant remaining. So that's our final answer. Question number 15. So for question 16, y is inversely proportional to the square root of x plus 1 when x equals to 8, y equals to 2. So y is inversely proportional. So we're going to take y, the fish symbol, 1 over the square root of x plus 1. So we're going to write square root x plus 1. Just write literally what the question says. So when we change it to an equal sign, we're going to put the proportion constant k above the fraction. It's always on the numerator, right? So from here, they told us that when x equals to 8, y equals to 2. So we can plug in some values to find k. So 2 equals to k over square root of 8 plus 1. 2 equals to k over 9, square root of 9. So in this case, you will have k equals to k over 3 equals to 2, k equals to 6. Right. So of course the square root of 9 will give us two values, but most of you will usually just take positive unless they mention otherwise. Right. If never mentioned otherwise, we will just take the positive answer. So from here, get y equals to 6 over square root of x plus 1. So when x equals to 99, y equals to 6 over square root of 99 plus 1. So we will get y equals to 6 over square root of 100, y equals to 6 over 10, finally y equals to 3 over 5. And this is our final answer. You may write it in fraction or in decimal, that's your choice. So moving on to question number 17 and 18. So for 17, we will have factorize p squared minus q squared. So if you recall, this is a formula that you must remember. A squared minus b squared equals to a minus b, a plus b. So you see, they just literally use a different unknown in this case. So straight away, you can say p squared minus q squared is p minus q, p plus q. That's about it. So in part B, p squared minus q squared equals 7 and p minus q equals 2. Find the value of p plus q. So in other words, you've already broken it down earlier. So p minus q, p plus q is equals to 7. So we know what's p minus q, which is 2. So 2 times p plus q equals to 7. In other words, p plus q has to be 7 over 2 because we're making p plus q. So for number 8a, so first of all, we have entire term covered the whole thing. So from here, the 3 over 4 is not only going to apply onto the y, it will apply onto the 81 as well. So this is a common mistake, please take note. So when we multiply powers, we also multiply it onto the constant. So 81 power 3 over 4, y 16 times 3 over 4 will be 12, right? So from here, y power 12 is done already. We need to apply the rules onto 81. So 81 basically is a fractional index. It will be the fourth root of 81, whole thing power of 3, y power 12, right? Or you can just use your calculator and count. So that would simply be 27 y to the power of 12. Yeah, that's done for number 8a. So lastly, for 8b, 2 power 3 equals to 4 power p. Find the value of p. So we have 2 power 3 equals to 4 power p. Make the base number the same first. So 2 power 3 equals to 2 power p. So since 2 power 3 equals to 2 to the power of 2p, we can compare the powers. This would be 3 equals to 2p, p equals to 3 over 2. So that's it for 18. And then for 19. So 19, model of a car has a scale. So we have this here. The model of a car has a scale of 1 to 20. The volume of the car is 12 meter cube. Find the volume of the model. Right. So just remember, whenever we are doing the ratios, the 1:20 basically means that for every 1 cm, it's 20 cm in real life. So 1 cm in the model is 20 cm in real life. Right, that is how we look at it. If they never give the unit, you can default the unit to cm. Right, that is how we usually approach it. Most math scales also approach it to cm rather than mm in this case. So what are we given? We are given the volume, which is 12 meter cube. Right, so first of all, we should just convert 12 meter cubes to cm cube first, because we are interested in the answer in cm cube. And furthermore, this scale is in cm cube too. So before we use the scale, we need to make the units the same first. So this will be 12 times. So meter to cm is multiply 100. In other words, for meter cube to cm cube, we have to multiply 100 3 times, or in other words, multiply 100 cube. So this would be 12 times 100 cube. So that would be quite high. So 120 million, is it 12 million or 12 million? So that's 12 million cm cube, right? So from here, we need to scale it back down. So since the model of a car scale is 1 to 20, and then we are gonna have to scale it back down to cm cube. So in other words also, we need to do one more thing, right? So what we normally would say is that this is applying the volumetric scales. So it would be the length of the model over the length of the wheel. I'll just put model and wheel as M and R. Or actually, we usually say image and object. This is what we usually will say, image and object. So the length of the image, put I, over the length of the object, we can make the ratio the same by cube rooting the volume of the image over the volume of the object, right? So in other words, we need to scale up our scale factor. So earlier on, the length of the image to length of the object is 1 over 20, 1 to 20 equals to cube root of the volume of the image is 12 million. And then the volume of the object is unknown. So from here, we cube both sides of the equation. You get 1 over 20 to the power of 3. So that would be 1 over 8,000 goes to 120 million over V object. So from here, we just cross multiply. So the volume of the object would be, sorry, actually I inverted the constants. So this one is it was 20 over 1, sorry. I realized when I noticed that the value became larger. So this would be 8,000 over 1, right? So when we cross multiply, this would be 8,000. The volume of object equals to 120 million. Sorry, 12 million. So volume of object would be 12 million divided by 8,000. So the volume of the object is just 1,500 cm cube, right? So that's that. So most of the time from here, most students make the mistake where they just straight away just take the volume and then divide by the scale. But remember, this scale is a length scale. So we have to write this out, right? Because they are asking us to calculate the volume from a length scale. So we have to cube root the volume in order to make the units the same. Because cm cube and cm is still technically not the same unit. Cm cube is a measure of volume, cm is a measure of length. So we have to make them the same through this making here, right? So that's for question 19. So moving on to number 20. So for number 20, we have 1 over x plus 2 minus 2 over 3x minus 1. So first of all, the denominators has to be the same. There's nothing that they have in common, so we can just multiply the denominators. We can just borrow the denominators and multiply. So we're going to multiply this side by 3x minus 1 on both the numerator and the denominator, whereas we're going to multiply by x plus 2 on both the numerator and denominator on the other side. So from here, what we'll get is that 3x minus 1 over 3x minus 1 times x plus 2 minus. So I put a bracket here, even though they don't write a bracket here, I put a bracket because I know the symbol is going to change. So 2x, I should have multiplied. So this would be 2x plus 4, whole thing divided by 3x minus 1, x plus 2. Right. So then from here, we will have 3x minus 1 minus 2x plus 4, whole thing divided by 3x minus 1, x plus 2. So I'm just going to keep this as a double bracket first. So from here will be 3x minus 1 minus 2x minus 4. Putting the bracket, change the symbols. And finally, we will have x minus 5 over 3x minus 1, x plus 2. So this will be finished. If you expand the bottom, it's fine. If you leave it like this, it's also fine because they want the fraction in its simplest form. Yeah. So either or is okay. So we have question number 21. So for question 21 itself, we have the pyramid. So the diagram shows a pyramid, square base ABCD of side length 8 cm. So the side lengths are 8, V is vertically above M, and VM is 10. So they say calculate the angle of VA and the base. So in other words, they are looking for this angle here. They actually drew it out quite nicely for us here. And we know that this is a right angle triangle. I will highlight it for you here. This V to A to M, and M to V is a right triangle, right? So if we were to just take out that right angle triangle, put it in a 2D plane here, So this would be VAM. Sorry, face A, B, and M. So this one is 10 meter, 10 cm, and they are looking for this angle. So from here, we can calculate what is the angle first by finding out one more of these lengths. Either we find this. So based on what we have at the moment, we know that this is a square base. So this is 8. So if this is 8, we can first find out what is the diagonal length because these two are 8 cm. So I can find the full diagonal by applying Pythagoras theorem on the bottom triangle. So in other words, I can find AC. So AC squared equals to, AC equals to the square root of 8 squared plus 8 squared. So that is just the square root of 128. So I'm just going to leave it in insert form, 8 insert 2. I leave it in insert form because we are able to take more decimals like this. So if AC is 8 insert 2, in other words, AM is half of AC. Or in other words, we can say it's half of 8 insert 2, which means this will be 4 insert 2. So from here, since it's 4 insert 2, now I know AM is 4 insert 2. So with two lengths available, I can now calculate my angle. So in other words, I'm going to use, because this angle, based on this angle's reference, this is opposite, this is adjacent, and this is hypotenuse. So I'm going to use TOA. So it be tangent of BAM equals to opposite over adjacent. So tangent of angle BAM is 10 over 4 sub 2. So I'm just going to shift 10 and I'll get my answer. So we take shift 10 off 10 over 4 sub 2, and that would give us 60.5 degrees, correct to 3 significant degrees. And that is for question 21. So with 21 done, we now have 22A and B complete. So 22A and B, some work here. So from here, these are the first 4 terms of the sequence. Write down the next term. So from here, 5, 8, 11, 14, we have just plus 3, and plus 3. So of course, the next term is plus 3 as well. So this would be 17. Right. So find an expression in terms of n for the nth term. So as I mentioned previously, there are 2 methods to do it. If you're given the progression itself, you can actually shortcut it. So to shortcut it basically is, it is Pn equals to An plus B. So your A and B is calculated in a certain way. So your A is very simply just the pattern. So because we see the pattern is plus 3, right? So straight away, since we know A is the pattern, so therefore A is just positive 3. Whereas for B is the first term minus the pattern. So in other words, it is positive 5 minus positive 3. So from here, symbols are important, yeah? So that's why I'm writing the symbols here. So that's why, because it's 2. So Tn equals to 3n plus 2. So for the alternate working is the formula I taught you previously. This is more useful for math in general, or when you're not given the sequence. So this is Tn equals to a plus n minus 1d, right? So from here, you can generate a couple, you can actually calculate it because you know the first term and you know the pattern. So you can just straight away plug in a and d, and that's your answers. Tn equals to 5 plus n minus 1, 3. So this is 5 plus 3n minus 3. And then we still get 3n plus 2 as the final answer, right? So that is for number 22. And then for B, we can see the fraction sequence. We have 1 over 2, 3 over 4, 7 over 6, and so on and so forth. So from here, when we look at the terms separately, like if we look purely at the numerator and the denominator separately, we may be able to observe something from here. Now, denominator is very easy to see. The next term for sure is 12. I can guarantee it because this one is plus 2, plus 2, plus 2, plus 2. So the next one has to be plus 2 as well. Now, top one is a bit interesting. We need to check. So the first 2 is plus 2, followed by plus 4, followed by plus 6, followed by plus 8. So the last one should be plus 10. So in other words, this would be 31 over 12. And that's not. So that is for question 22. Now, question 23, you may skip because 23 is part of your syllabus. This is matrices, so please do not do the matrices question. So for 24. So in question 24, we have the speed time graph. So they said diagram shows information about the final 70 seconds of the car journey. Find the deceleration of the car from 60 to 70. So we have coordinates to play with here. So this is 60, 20, and this is 70, 0. So why I want the coordinates is because deceleration or acceleration serves as the gradient of the speed time graph. So since I know that it is the gradient of the speed time graph, I can then conclude that for A, it would just be 20 minus 10. A equals to 20 minus 10 over, 20 minus 0, yeah, over 60 minus 70. So that is 20 over negative 10. So it's negative 2 meters per second. So that's A done. So the next one is B. Find the distance traveled by the car during the 70 seconds. So for the speed time graph, distance is the area under the speed time graph. So if we split out our areas into two parts, I call this A and I call this B. So the area of A is just a rectangle. So it would just be 20 multiplied by 60. So that would be 1,200 meters. Whereas area B would simply be area of triangle, half times 20 times 10. So we take 10 because this distance here is 10 and this distance here is 20. So from here we will have 100 meters. So the total distance traveled is 1,200 added with 100. So that's 1,300 meters. So that's done for 24. And then moving on to our final two questions. So first of all, we have the 25. Start. So for question 25, OABC is a parallelogram and O is the origin. CK equals to 2 kb. So CK equals to 2 kb. I can just put CK as 2 parts and kb as 1 part. Right. So AL equals to LB. So means L is the center. Right. So this is 1-to-1 ratio. So M is the midpoint of KL. Again, this is another 1-to-1 ratio. Right. So OA equals to P, OC equals to Q. So if OA equals to P, OC equals Q, they ask us to find what's KL. So to find KL, we are just working backwards. So if we work out our vectors a little bit, now this whole thing called O to A is P. C to B also has to be P because this is parallelogram. So we can, from our ratios, we can work out what is each individual value. So in other words, CK would be 2 over 3P. Whereas KB would be 1 over 3P because this is 2 parts, this is 1 part, total is 3 parts. So we have 2 parts of CK and 1 part of KB. So it applies for AL, LB as well. This will be 1 over 2Q, and this will also be 1 over 2Q because they are split half. They are equal to each other, right? So from here, we can count out KL easily. So KL would simply be K to C plus C to O plus O to A plus A to L, right? So basically, I'm taking a track moving from K. Actually, I don't even need to go that far back. I could just go forward, actually. I just come to think of it. It would just simply be KB plus BL. I'm not sure why I took such a long track, right? So it would just be KB plus BL. But anyway, if you did the other one also, you still get the same answer regardless. So it's AB, BL. So KB is 1 over 3P, BL is 1 over 2Q, right? And that's done for question A. So for question B, they are asking for the position vector of M. So the position vector of M, whenever they ask about position vector, they are merely asking about what is OM in general. So OM in this case would simply be checking our track from O to M, we are just going from O to C, O to K, O to C, C to K, and then finally K to M. So OCCK is fine. OC is Q. CK is yes, sorry. I made a mistake on the first question. Yeah, it is not plus 1 over 2Q. It is minus 1 over 2Q, yeah, because it is going in the opposite direction. So it's 1 over 3P minus 1 over 2Q going in this direction. So it would be OM equals to OC plus CKKM. So OC is Q. CK is 2 over 3P. And finally, KM, we don't know what's KM, but I know that is half of KL at least, right? So from here, I can just count out half of KL. So half of KL is simply just half of what I counted earlier. So KL is 1 over 3, P minus 1 over 2Q counted above. So Q plus 2 over 3P plus 1 over 6P minus 1 over 4Q. So this is 3 over 4Q plus 5 over 6P. And that's done. 1 over 5. So for our last question, 26. So for 26, we have line L passes through the points, so and so. So find the equation of the line. So to find the equation of the line, we have the y equals to mx plus c basic form. So they already gave us the y-intercept here. So y equals to mx minus 3. And we can find the gradient very quickly. It would be 9 minus negative 3 over 6 minus 0. So that is 12 over 6, which is equals to 2. Therefore, the equation of the line is y equals to 2x minus 3. So we can get that really quickly. So for part B, find the equation of the line that is perpendicular to L and passing through the point 0, 2. So perpendicular to L means that M1, M2 equals to negative 1. So 2 and 2 equals to negative 1. The gradient of the perpendicular line will be negative 1 over 2. So if you don't want to show this working, you just need to state it, right? Because you just need to flip the gradient and place a negative 1 to it. And they told you that they pass through 0, 2. 0, 2 is also a y-intercept, so your work is cut out for you already. So it's just y equals to negative half x minus 2, plus 2. And that's it. So that's all for paper 2-1. So if you have any further questions, you may ask me when I'm back, or if not, you may proceed to the next video. See you all soon.